Before we look at the simplification, it is important to know or identify like and unlike terms. So like terms have exactly the same variable and the same power. So in example 3, Roman 1, 2a and 3a are like terms because the variable is the same, a, and the power to which the a's are raised is also the same. In Roman 2, a and a cubed are unlike terms because even though they have the same variable, that is a, in the first case a is raised to power 1 and in the second case a is raised to power 3. So the powers are not the same. In Roman 3, we have 4ab and 4b. So these are unlike terms simply because the variables are not the same. In the first case we have AB, in the second case we have only B. So therefore, to simplify any algebraic expression, it is important to identify the like terms and put them together. For instance, in example 4, we are required to simplify 4s plus 2t minus 5t minus 3t. So when we put the like terms together, we are going to have 4s minus 3s plus 2t minus 5t. So that would give us s minus, let's look at the use of brackets. In example 5, we are required to remove the bracket and simplify. So we have 4 into 2a plus 3 minus 3 into 5a minus 6. So in the solution, the first step is to remove the brackets before we even talk about simplification. So if we open the first bracket, we are going to multiply all the terms in it by 4. So in this case, we have 4 times 2a gives us 8a plus 4 times 3 will be 12. Then minus 3 times 5a for second bracket will give us minus 15a, and minus 3 times minus 6 will give us plus 18. So if we collect like terms, we are going to have 8a minus 15a plus 12 plus 18. And the result will be minus 7a plus 30, which can be written as 30 minus 7a. So here we want to stress the fact that negative sign before bracket will always reverse the sign of the terms inside the bracket when removed. So the process of removing brackets is called expansion, and the reverse is called factorization. So we can still look at more examples. So we have in example 6, Roman 1, we are required to factorize 3p plus 2r plus 3q plus 3r. So in our solution, what is important here is that in factorization, we always look for the common factor in all the terms. But before we do that, there is need to simplify by putting like terms together. So remember, we have 3r and another 3r. So when we put them together, we are going to have 3p plus 3q plus 6r. And then since 3 is common, 3 is common factor, so we factor it out, and therefore inside the bracket we'll be left with p plus q plus 2r. So the answer is therefore 3 into p plus q plus 2r. We can also have factorization by pairing, and that is what we want to see in Roman 2. So in this case, we are going to pair ax and a because they have a in common, and bx and b because they have b in common. So that when we bring in the brackets, we are going to have a into x plus 1 plus b into x plus 1. And again in this case, x plus 1 is common, so we have x plus 1 into a plus b as the answer.